Hello, this lesson is about proving triangles congruent. So we now have our 5 shortcuts to prove 2 triangles congruent. So we're going to use them to actually write a proof. So the EQ came out of several students that I talked to, have been concerned about, well, Ms. Mendoza, how do you know about the geometric proofs? And they're a little confused about how to do one, and they're all different, so I can understand the confusion, and there is no set way to do it, but there's some strategies that may help you. All right, so let's think about this proof. Take a moment. And that's one of the first things. You really want to look at everything. You want to look at your given. You want to know what you're proving, and you really want to look at your diagram and see how those things are connected or if they are. Okay, so I'm going to go to the diagram. I like to label my given one at a time. So I'm like, okay, and I need to prove this is equal to this. Now, I'm not going to mark it in because I'm going to think it's a given. So always go backwards. So I'm going to start with the given. And that's always a good place to start. All right. And then I'm going to ask myself, is there anything more I can conclude from that? Nope. Is there any other givens? Nope. Then I'm going to go to the diagram. All right. From this diagram, is there anything? Remember my question. My question I always tell you is, what do you see? Well, I see this kind of funky shape, and I see that there's 4 angles. 1, 2, 3, 4. Okay. So from what you see, what do you know? Well, over here, I know that those 2 angles are vertical. And if they're vertical, they're congruent. Ah, okay. Well, let me write that down before I forget. So, and I may not know where I'm going, and that's okay. I think students often are like, you have to know the final answer immediately, and if they don't, they just give up. Nope. You just write something down and hope for the best. Okay. And then for me, I like to be like, okay, can I conclude anything from those 2 lines? Now, you can add other lines, and here's the thing that's confusing for some. There isn't always a straight path. You can maybe do a different line after it or between it, and we'll talk about it in a moment, maybe after I have more lines. So if I'm looking at these 2, I can see that angle 2 is the same. Well, if they're both equal, angle 1 and angle 3 are both congruent to the same angle. Well, that must mean that they're congruent to each other. And that is the transitive property of congruence. All right. Is there anything else we can conclude from that? Nope, don't. All right. Well, let's go back to the diagram. Okay, what else do I see? Well, I saw that 1, 2, and then I was going this way. So now I see 3 and 4, and those are congruent to each other. Where are they congruent? Because they're vertical. All right, that's another line for me. So angle 3 is congruent to angle 4. And we said vertical angle theorem. Yay. Okay. And then, then I'm going to take these 2 lines. Is there anything I can conclude? Well, again, I see that these 2 are equal now. Well, oops. Well, if angle 1 is congruent to 3 and 3 is congruent to 4, that must mean 1 is congruent to 4. And that is, again, the transitive property of equality. Now, is there anything else to conclude? Oh, no, wait, look. That's what I was proving. So if that's your last line, we're done. Done. All right, so let's go back and do some thinking. Now, it doesn't have to be in this order. The given actually could have been line 2. I could have maybe written angle 1 is congruent to angle 2 first and put vertical angle theorem. And I even could have put angle 3 is congruent to 4 with them. So I could have done these 2 lines together if you wanted to. And then done a bunch of transitives. This one has to be at the end, right? So the order of how they isn't as necessarily important for all the lines. Like I said, this last line has to be at the end because it's what we're proving. But the other ones, we could have had some other things moved around. Okay. So next one, congruent triangle. So take a moment and write down all the shortcuts that you know. There should be 5 of them. And unpause when you're done. All right. Now this one, and this one, and this one, and this one, and this one. So side, side, side. All right, so hopefully you make some shortcuts and you're drawing it. Angle, side, angle. Oh, sorry, side, angle, side. So it's the angle in between. This one is angle, side, angle. And the side is in between. This one is angle, angle, side, angle, angle, side, and HL. 2 right triangles, hypotenuse, and a leg. So in your homework, you had a problem like this. They gave you some things and said, are the 2 triangles congruent? And if so, write the congruent statement and then the reason. Well, let's look. Here's my given. So I'm going to mark it. This is equal to this. Okay. Segment BC congruent to segment DC. So if I'm looking at my shortcuts of all 5 of them, going back, I have 2 sides. So if I have 2 sides, I only have 2 choices. I either find a 3rd side or an angle in between the 2 sides. So that's another way to use, when you're doing congruent triangles, is looking at your shortcuts and seeing what you're given. So, well, it doesn't tell you anything but the angle, but I do know that this side, AC, is in both triangles. So I believe, yes, they are congruent. Now this is my congruent statement, which might be a little bit different than your congruent statement, as long as the parts correspond. And my reason is I have a side here, a side here, and a side here. So that's side, side, side. So this is what we have done in the homework, and it was to prep you to actually do proofs. So I'm going to take this and actually write a proof for it. Now, before we do, remember, for the reasons we can use postulate theorems, definition, properties of congruence, or properties of equality for congruent triangles. It would be properties of congruence, and our favorite, given. Oh, I didn't prove it. Oh, that's right. I'm sorry. I actually changed the proof. My bad. So we're going to prove this one instead. I think you could have proven that one. Maybe for extra practice, you can prove the one that we just did. Make your own 2-column proof for this. All right, let's try this one. Okay, so I'm looking at my given. All right, I have a pair of angles and a pair of sides. And I'm trying to prove L and M is congruent to O and P. All right, so I'm going to start with a given. So angle L is congruent to angle O. Given. Mark it. Okay. Is there anything else can do with that given? No. So I'm going to go to the next one. Next given. OP. Given. And LM, segment LM is congruent to segment OP. Now, I'm going to write them here. Hopefully, after a while, you'll memorize them. But I'm going to write them down. And I know it's not a right triangle, so I'm just not going to put HL. Because I have a side and an angle, I know it can't be this one, right? So I'm either looking for another side or another angle. All right, so let's look. Let's look at the diagram. Is there anything else we know? Anything we can conclude, right? What do we see? We have two triangles. I don't know if anything is parallel. Oh, but again, we have our nice vertical angles. Okay, great. Now, class, if you tell me this, angle N is congruent to angle N, I'm going to mark that wrong. You're like, but you just wrote it. Yes, I know it is to tell you that's wrong. The reason why, there's actually several different angle N's. Do you mean this angle or did you mean that angle? So I'm going to actually need 3 letters and not just one. Okay. So I'm going to say angle LNM, which is this angle here, and angle ONP, which is this angle here. I'm going to say they're congruent. So again, for this one, I needed 3 letters because there's more than one angle there. As opposed to angle L, I know which one that is. That's only this one. That's all we have in that diagram, right? So now having these things, I've marked it up a little bit. I know I have 2 angles and a side. Now here it looks like angle, side, angle, but you have to look at the diagram. Okay, so let's look at the diagram. I have a side here, an angle, and the angle. Is that side between the 2 angles? The answer is no. So we're going to go with angle, angle, side. So my 2 triangles are triangle LNM is congruent to triangle ONP for reason why, angle, angle, side, right? So we know that if you're doing congruent triangles, right, proving this is what we're proving, you need 3 things. And we had 3 things, and there you are. Okay, hopefully that one makes more sense. Let's try another one. Okay. All right, so this one, again, we're going to take a moment to really look at it. Just don't write down the given, really look at what you have. All right, I have 2 givens. This time I have a midpoint of AC, which is down here, okay, midpoint. And I have BC equals over here, okay, so that's over here and here. And I'm proving the 2 smaller triangles congruent. Okay. Now, another strategy that we often think about is going backwards. I know, even if I don't know what's in between, if I'm stuck, I'm really stuck, I know this is the end, right? And so you can write that. I don't know why. I don't know what number of lines, but I know that's my last thing. So then just write it there. Okay? So I know if I'm doing 2 triangles congruent, remember I have 5 possibilities. Okay, kind of looks like a right angle, but I'm not sure. It doesn't say anything about it, but I'm just going to write it down anyway. Oops. Okay. Angle, side, angle, 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 side, and HL, just in case. All right, so what I generally like to do, I take one given and I work with it. Now I need 3 pairs of things congruent. Now, does this tell me that it's congruent? No. But does it help me get something to be congruent? Yes. So if D is a midpoint of AC, what do I know? Well, if this is a midpoint, then I know that this equals this, right? The midpoint divides the segment into 2 equal parts. So I know it's equal, but you can do congruent. Right, 2 congruent, right? The 2 congruent parts. And why is that? Well, isn't it just what we said? It was the definition of a midpoint. Another good clue to know it's a definition, it has a word midpoint. So maybe the definition. Pretty good odds for that. Definition of a midpoint. Okay. So is there anything else I can conclude from that? Nope, none whatsoever. Okay. So then if there's nothing more, then I go back to the given and say, are there any more givens? Yes. There's one more given. So I'm going to write that down and say that's a given. Now you could put both givens up at the first line. That's fine. So the last time I did that, I forgot about the given, and that was my bad. So there's, again, more than one way to write a proof. All right, now because I have two sides looking at my diagram, I know it's not this and not this. Now someone can say, well, Ms. Mendoza, isn't that a hypotenuse and leg? Does it say it's a right triangle? No, it doesn't. So I cannot assume, even though it looks like it, that it's a right triangle. Now there's probably some other ways to prove it, but I think the simplest way would be, what else do we know? Right? I know that that side is congruent to itself, right? And what's that reason? Reflexive. Reflexive property of congruence. Okay, and then what do we have? Three sides. So that's going to be side, side, side. Excellent. Now I'm sure someone's going to say, well, Miss Mendoza, the two sides are congruent, so couldn't we do the angles? Yes, you could. You could do that. And then for the reason, it's, you would have to write the isosceles triangle theorem, or literally write out the sentence. If two sides of a triangle are congruent, then the two opposite angles are congruent, which is fine. You could have done that as well. All right. Hopefully this helps you to understand proofs. And proving two triangles congruent, I think, is a little bit easier for the geometric proofs, because you know you're going to use one of these. And for these, you need three things every time, right? Three sides, two sides at an angle, two angles inside, two angles aside. For this one, there is three things you have to prove. You actually have to prove first it's a right triangle, then HL, the hypotenuse and the leg. So that's three things for that one. All right. Don't forget to answer the EQ. Until next time, be safe, be well. Bye.